Good day everyone, my name is Irish Baraka and we will be discussing about CATT and Aspen for software application. First and foremost, I will be tackling the history of CATT or computer-aided thermodynamic tables in three dimensions. It is specialized software developed for thermodynamic property calculations and heat transfer analysis. The development of CATT3 starts when engineers and researchers were struggling with the manual calculations of thermodynamic properties of different fluids. Innovation in CATT3 started in the late 20th century, where it started to become more efficient. The software was designed to assist engineers and researchers in handling complex fluid systems. CATT3 focused on accurate property data for a wide range of fluids under diverse conditions. Its unique three-dimensional representation of thermodynamic data allowed users to visualize these properties more effectively.
Thank you, Irish Bea. So now, let us discuss the industry application of CATT. So to give some introduction or briefly explanation about industry application of CATT, CATT or computer-aided thermodynamic tables in three dimensions is a specialized software tool used in engineering for thermodynamic property calculations and system simulations. It has gained widespread use in both industry and academia due to its user-friendly interface, accurate data handling, and ability to simulate various energy systems. So for the industry application of CATT, number 1, simulation of thermodynamic cycles. These paragraphs explain how CATT is used to simulate thermodynamic cycles like the Rankine, or used in steam power plants, and Brayton, used in gas turbine cycles. These cycles are the backbone of energy systems and power generation. So the purpose of this is engineers simulate these cycles to see how they perform under different conditions. And the function of CATT, it calculates important values like thermal efficiency or how well energy is converted on work output and heat input, all crucial for improving power plant performance. So for number 2, the optimization of fluid systems. This section highlights CATT's use in designing fluid systems, especially those that handle gases and liquids under pressure and temperature variations. So who are the industries involved in this? Number 1, power plants, cooling systems, and refrigeration industry. So what CATT does, it helps in choosing the right working fluid like refrigerants, reducing energy losses, and ensuring that calculations are thermodynamically correct. Why it matters? Even small errors in fluid systems design can lead to energy waste and performance problems. So for number 3, design of energy efficient HVAC and refrigeration systems. Here, the focus is on how CATT helps design HVAC and refrigeration systems, which are found in building, vehicles, and industrial setups. So what engineers use it for? To compare different system designs, select efficient refrigerants, and estimate how much energy systems will use, and why it is important. Choosing the right design and fluids leads to lower electricity bills, higher efficiency, and less environmental impact. So number 4, heat energy analysis. This paragraph discusses heat exchangers, which are devices that transfer heat between two or more fluids. They are used in power plants, engines, HVAC systems, and more. And how CATT helps? It allows engineers to simulate heat transfer and calculate how efficiently heat is moved from fluid to another. And the result is better design and performance of heat exchangers, making system more reliable and energy efficient. So for the last one, support for renewable conventional energy systems. This part shows that CATT is versatile. It supports both renewable energy systems like solar thermal Engineers use it to model systems that store or convert heat energy sustainably. In conventional systems, it is used to improve performance or upgrade older systems. And the impact of CATT is CATT contributes to cleaner and more efficient energy technologies. Academic use and training. This paragraph shifts from industrial use and to how CATT helps students and teachers in universities and college. And students use it to visualize how thermodynamic properties and pressure and humidity change. One of the key benefits or the benefit of CATT is to give data in tables and graphs for easy understanding. And subsequent goal for this is thermodynamics, fluid mechanics, heat transfer, and the result is student gain hands-on experience and better understand complex theories.
Now let's talk about the industry applications of Aspen Plus. Let's start with the chemical industry, which is one of the primary sectors where Aspen Plus really shines. It helps engineers simulate and improve a wide range of chemical processes. It stimulates and optimizes processes like distillation, reaction, and absorption. It enhances process efficiency, cost effectiveness, and product quality, and assists in troubleshooting and design of chemical plants. So, in the chemical sector, Aspen Plus is essential for optimizing operations, cutting costs, and improving process control. Now let's move on to the petrochemical industry. This is another major area where Aspen Plus is heavily used, especially for refining processes and hydrocarbon modeling. Models refinery operations and hydrocarbon processing. It also supports crude oil refining, process configuration, evaluation, and energy integration. It enables safer and more efficient plant designs. So in the petrochemical field, Aspen Plus helps optimize complex operations, improve plant safety, and boost overall efficiency in refining and processing. Now shifting to the pharmaceutical industry, Aspen Plus plays a key role here too, especially when it comes to scaling up lab processes and ensuring product quality. It is used for API or active pharmaceutical ingredient production and processes scale up, models reaction kinetics and crystallization processes, and ensures product purity, consistency, and regulatory compliance. As you can see, Aspen Plus supports both the development and scale-up strategies in pharma, making it easier to produce safe, consistent, and compliant medications. Moving on to the energy industry, Aspen Plus is a valuable tool for modeling energy systems, especially in the production of biofuels and integration of renewables. It supports biofuel production, like ethanol and biodiesel, and renewable energy integration. And it also assists in energy efficiency analysis and optimization. In the energy field, Aspen Plus helps improve energy efficiency, explore alternative fuel options, and support sustainable development. Now let's talk about its environmental applications. Aspen Plus helps industries understand their environmental impact before they even build the systems. Overall, it plays a crucial role in reducing emissions and guiding companies towards cleaner, more responsible practices. Aspen Plus is really useful for environmental work. It helps predict emissions and shows the impact of a system before it's built, so companies can reduce pollution early on. It also supports carbon capture and waste reduction efforts. And for sustainability and compliance, it helps industries meet regulations and design safer systems. It can simulate risk and energy use, which make decision making easier and more responsible. So overall, Aspen Plus helps industries work smarter, cleaner, and safer across the board.
Thank you, Ron Kaiser Ferreira. Now, let's discuss about the comparative advantages and disadvantages of CATT and Aspen Plus. So, let's start with CATT advantages. First, its precise thermodynamic data. It provides accurate property data which is essential for detailed energy analysis. Next is easy to use interface. Its user-friendly design simplifies learning and usage. Next is excellent educational value. It is a great tool for teaching thermodynamics concept like for students. And last, effective for thermodynamic cycle modeling. It is ideal for analyzing cycles like Rankine or Brighton. Next is CATT disadvantages. First is its limited 3D modeling. It cannot handle complex spatial or geometric simulations. Next is its lacks modern updates and integrations. It is not frequently updated, so it has limited compatibility with newer tools. And last, specialized use limits versatility. It is mainly focused on thermodynamics and not suitable for broader engineering tasks. Now, let's move on to Aspen Plus advantages. First, its robust simulation capabilities. It can model complex chemical processes with high accuracy. Next is extensive chemical database. It includes thousands of substances and reactions. Next is integration with other tools. Aspen Plus actually works well with other Aspen products for end-to-end process design. Last is support sustainable and energy-efficient designs. It is useful for optimizing green and energy-saving processes. Now, let's talk about Aspen Plus disadvantages. First is high cost. Its expensive licensing makes it less accessible. Next is steep learning curve. It requires significant training to use effectively. Next is high system requirements. It really needs powerful hardware to run efficiently. Next is its complexity. It's not ideal for simple tasks. It can be overkill for basic thermodynamic or process simulation. Now, that's all for me. Thank you. Next reporter will be Adrian Gregorio.
Good day everyone. I'll be discussing about the educational and design value of CATT and Aspen Plus. First, we will talk about CATT in education. CATT is a strong educational platform for teaching thermodynamics. It helps students simulate thermodynamic cycles and reprocess theoretical concepts through visual and tabulated outputs. So in simple terms, CATT is a really helpful tool for students because it is help us see how the thermodynamic cycles work in real time, like the Rankine and Brighton cycles. It's not just pure theory. We can actually simulate and see the results. The tables and graphs it provides make it easier for beginners to understand what's happening in those processes. The next one is the design value of CATT. CATT is ideal for basic thermodynamic cycle modeling. It is useful for designing HVAC systems, refrigeration, and energy systems in simple applications. Its user-friendly interface makes it easier to learn. Now that we have talked about how CATT helps us in education, it's also great for design purposes. CATT works best for simple systems. For example, if you want to design a basic HVAC or refrigeration system, this tool can help you model how the cycle will work. Since it's easy to use, students and new engineers won't have a hard time to learn how to operate it. Now we will talk about the Aspen Plus in education. Aspen Plus is widely used in higher education and professional training. It offers detailed simulations that help us students and professionals understand chemical and industrial processes and study environmental impacts. Now, shifting gears to Aspen Plus, which is more advanced compared to CATT. It's usually used by engineering students and professionals. Aspen Plus can simulate entire processes, so a student can learn how a full chemical plant operates. It's also great for analyzing how we can reduce waste, emissions, and other environmental effects in the industrial systems. The design value of Aspen Plus is used for complex industrial process designs. It can model entire plants, reactors, heat exchangers, and separation of units. It also includes sustainability tools like carbon capture and energy recovery systems. To wrap things, when it comes to design, Aspen Plus is perfect for bigger or more complicated projects. For example, in real industrial plant, you can have different units like reactors and heat exchangers. Aspen Plus can simulate all of them together. It also has special features for sustainability, which help industries reduce their carbon emissions and recover energy, making their operations more environmental friendly.
CATT and Aspen Plus integration and sustainability. CATT integration capabilities. CATT operates primarily as a standalone software tool focused on thermodynamic analysis. It is not built for integration with larger process designs or simulation suites. This means it doesn't connect or share data directly with other engineering software like simulation or optimization platforms. Despite this limitation, its focused design makes it reliable and simple to use for specific calculations related to energy systems. CATT offers sustainability role. Though CATT lacks direct environmental modeling tools, it supports sustainability by helping users analyze and improve thermodynamic cycles like Rankine and Brayton cycles by calculating parameters like enthalpy, work outputs. Users can design systems that use energy more efficiently, leading to reduced fuel consumption and lower emissions in practical applications. Aspen Plus integration. Aspen Plus is built to work in harmony with other Aspen Tech software like Aspen HYSYS, Aspen Dynamics, and Aspen Optimization. This integration allows engineers to design, simulate, and optimize processes from the start to finish using single suites of tools. Data can be transferred between applications without re-entry, improving accuracy and efficiency. Aspen Plus sustainability features. Aspen Plus supports modeling for a wide range of sustainable technologies. Users can simulate carbon capture and storage (CCS), biofuel production, waste heat recovery, and other green processes. This software also helps evaluate energy efficiency and calculate emissions, allowing companies to meet environmental regulations and design cleaner systems.
In conclusion, CATT3 excels in thermodynamic and heat transfer analysis, making it suitable for educational and research purposes in HVAC and refrigeration. However, its 3D modeling is limited, and its specialized focus reduces its overall versatility compared to more modern tools. In contrast, Aspen Plus is a dominant process simulator, particularly in chemical, petrochemical, and energy industries, offering extensive capabilities for complex process design and optimization. Despite its power and integration with other Aspen Tech tools, Aspen Plus has a higher cost, a steep learning curve, and significant computational demands, making it less accessible for small entities. Ultimately, the choice depends on the user's specific needs, with CATT3 favoring simpler thermodynamic tasks and Aspen Plus being ideal for comprehensive industrial process work. That concludes our discussion about CATT3 and Aspen Plus software application. I hope you learned a lot and thank you.